Okay, hello everyone, and welcome to another EESSI Happy Hour session. That is every Monday between 2 and 3 p.m. Today we are still in the topic series of building on top of EESSI. And in today's session, we will see how to build on top of EESSI using the built-in modules. So within the topic series, building on top of EESSI, we have earlier seen how to use the EESSI Extend module. In the previous session, we saw how we build software on top of EESSI. And today we will have a look on a different approach of how to build software on top of EESSI using the built-in modules. So I will first go quickly to what EasyBuild is. So EasyBuild is a framework for building and installing scientific software on HPC systems in a consistent, reproducible, and automated way. How it works, it uses EasyConfigs. EasyConfig is a configuration file that describes how to build a specific software package. EasyBuild automatically takes care of dependencies and libraries required for building the package. It also ensures that the software we build is reproducible across clusters and other architectures. And to close the quick summary for EasyBuild is widely used with Easy, and it also integrates with L-Mode, and in Easy we also use it with CVMFS and other packages. So in the previous session, or the first session in the topic series, we saw that we can build on top of Easy using EasyBuild. That is within the Easy Extend module. But another way to build software on top of Easy is using built-in modules. But why would we use the built-in modules? In general, to build on top of Easy and to use EasyBuild, we said there are EasyConfig files required, which are like configuration files to describe how to build the software. But what if this configuration file is not available yet? Maybe I am trying to build a software that is a bit new and the easy config file is still not there. Or maybe I am trying to build a new software on an older tool chain that, again, it misses the easy config file. That doesn't mean that at a later stage we cannot contribute and try to make a pull request for that easy config. But again, whenever we are trying to build, it's not available, we can try to make up this easy config file. But first, we need to try to build the software, and then we can create the easy config so that we can do the contribution. So to do that, we can use the built-in module within Easy. So first, we initialize Easy using either of the approaches we have shown earlier. So it's either sourcing the bash script or using the L mode or even using the easy container. And then we load the built-in modules. So maybe it's better to jump into the live demo and show what the built-in modules and how we can use them. So this is the usual happy hour VM, but today I recreated it because I need to compile software with the built-in module, so I need more memory. But for now, I will do two things. I will first try to initialize easy, and that is like so because on this system, I already have access to CVMFS. And again, just as a reminder, I can do that by ls/cvmfs software.easy.io to check if I have access. And I can see that I do. And then I can source/cvmfs software versions init bash. By doing this, again, a quick review, it detects the CPU microarchitecture in the environment, and that is Haswell, Intel Haswell. And also it detects if I have a GPU, which I don't. And it then offers me the best software stack, the best of the optimized software stack from within EESSI so that I can run my scientific software from. Now that I have loaded EESSI or initialized EESSI, if I do ml avail buildenv, I can see that there are three different versions of buildenv. So each of those is targeting a specific toolchain. As you can see, there is the 2022B, 2023A, and 2023B. Why those toolchains? Because in EESSI, with EESSI version 2023.06, we do support those three toolchains. Next, what I will see is that I will try to compile a simple software. First, I will try to compile a simple hello world. For that, I prepared the simple hello world C file. So that is, if I go to MPI, I can see that here I have a simple C code hello world file. What I will do next is I will try to load the buildenv module. So ml buildenv default, and I will go for the 2023B. Let me use the latest one. Now that I've loaded the module, if I do module list, I can see that it has loaded the GCC core, the GCC, and the whole FOSS toolchain required so that I can build on top of EESSI and rely on the underneath available software from EESSI for toolchain 2023B. So if now I simply do mpicc hello world.c -o hello world, and to check if I do an ls, I can see that it has created the binary. And if I do mpi run -np2 hello world, I can see that it runs as expected using MPI and on rank 1 and on rank 0. Maybe you could consider this as a very simple test. I will try further and go and try to compile OSU micro benchmarks. So if I go to OSU, I can see that what I've done is to spare some time, I've downloaded the OSU micro benchmark 7.5.tar. But why this specifically? Because if I go to easy configs, as I said earlier, easy configs, and if I go to O to see what is the latest available, also micro benchmarks, I can see that the latest 7.5 easy config is not available for toolchain below 2024, sorry, 2023B with CUDA. So yes, it is not available for 2023A or B. So the lowest toolchain supporting is 2025A for the version 7.5. So what I will try to do is I will try to compile OSU. So for that, I already untarred the compressed file. So I will go to cd OSU. I guess I already created the build folder. Yes. And again, with the already loaded software that is through the built-in module 2023B, I will try to go with. So what I would do is I just went through the OSU micro benchmarks documentation, and so how can I compile the software from source file? And basically this is what I need. I don't have any GPUs on the system, so I don't have neither CUDA nor ROCm, and all I need is, again, through the documentation, I can see that I need to specify the C and the C++ used during compilation. So now if I do this, it will try to create the make file. It shouldn't take too long. Yes. And now if I do make, it will try to create the binaries. So after this is done, as you can see, it is already linking against the software available through CVMFS. I'm not sure if you can follow up with the screen I'm showing. After this is done, I will try to run the OSU that I've built, and then I will also try to run OSU from within EESSI. It shouldn't take too long now. It's, I guess, almost done. So just as a reminder, I'm doing this because I don't have an EESSI config available. So I am trying to compile the software. If it succeeds, maybe then I think of contributing or making a PR. So until then, I need to have a successful process. So as you can see, this is done now without errors. So if I try to run what I've created, so if I now try to run MPI run, which is basically, let me try to show you first. I'll do this and where it has created. So now I am in the build, and if I do ls c MPI standard startup p point to point and standard, I can see that the binaries are found here. So what I will do next is I will go to cdc and try to run MPI and to run MPI run. And I can see that it is executing the binary that I created. It is different than what is available in CFMFS. And one thing also I should mention is that doing this is very good, but again, you need to have enough knowledge on to know how the runtime linker works and how things are linked together, because things could look simple, but when you're trying to compile a bit complicated software, you need to have a knowledge in this. Plus, when you are using such a compilation, you need to make sure that you cannot run the software you have compiled on another architecture. So basically, you are linked with what you are trying, with the environment or the architecture you are compiling on. So this is the also micro benchmarks binary I built. But if I also check within EESSI, so if I do ml avail OSU, I can see that there are also different versions already available from EESSI. Again, if I load one of those, so if I do ml, and now if I try to run MPI run OSU, let me first check which OSU am I running. So echo dollar which OSU bandwidth, for example, I can see that it is picking up the one from CVMFS, and that assures that I'm not running the one I compiled. And if I now do MPI run or soup. And this is the one built within Easy. So for today, I have shown you how to compile software using the built-in environment. And I hope that this has been a useful session. There is one more surprise for today, and I guess our colleague could explain more. Ellen, could you hear me?
Yeah. Could maybe tell people a little bit about what's going on behind the curtains in that build-env module.
Mhm.
So that build-env module, all it's doing, it's not um, crazy complicated or something. What it does is it looks at a typical environment that we use when we're compiling things with easy builds. So like a configure make environment. So it sets a lot of environment variables that are typically useful. So things like CC, CXX, C flags, F flags, F90 flags, all of these kinds of environment variables that generally have an impact. And so I didn't catch it. Which build system you had there? Was that a CMake for your tool or for OSU benchmarks? Was that CMake or
Yeah.
configure make?
No, it was configure make.
Configure make,
Yeah.
right? So it would have worked perfect with that environment, right? So great, you have configure make, and so it's more or less designed for that. It probably works really well with CMake based configurations as well. Um, and then the other thing that it does is it wraps the compilers. So it does the RPath thing and that we use within Easy, right? Because we're like a side operating system and it solves that problem for you and make sure that you're using um the right dependencies. So it sets RPath, so you're always going to very specific locations. And so that's more or less the reason that it works. So I think maybe that's important information for people. The other thing is a caveat, and it doesn't work miracles, right? So it doesn't mean that everything you try is going to work.
Yeah.
And there's a reason that Easy Build exists, and it's because things are not that simple. If things were as simple as I just need a compiler, I load some module, and miracles happen, and Easy Build wouldn't exist. So it's not going to solve every single problem for you. But it might help in quite a few different situations.
Yeah,
Okay,
and users can
sorry.
try to use that before preparing the recipe. That is the easy config file, right?
Yeah, yeah. So for a lot of cases, you should be able to play around with it, right? Um, but in the cases where a compiler wouldn't have worked anyway, it's not going to fix that problem, right? So if although it probably would help, right? So these environment variables, they're a bit sneaky because you load the module, you don't know all of a sudden that there's tons of environment variables that have been set. Um, they might help. So some of those might help. So things it's telling you about the math libraries and things like that. And so whatever you're using, it may pick up on these things and maybe start to work or break all of a sudden, because they're being used. So yeah, the thing that I wanted to talk to you about is just something I created a blog post about this the end of last week. It's still under review, so it's not public yet. So I guess this is a preview of that. Um, If I can share my screen, I can show you the post
Yeah, sure.
uh, and let me take over then. I can send a request. Okay, so I can share this one. And I need to close this. Well, I can go here. No, go here. So this is a preview of the post. This is what's under review at the moment, and it's about making easy available on EOSC. So what is EOSC? That's in the blog post. So that's the European Open Science Cloud. And I'm just going to show you quickly what I did to make it available there. And and basically, not to get too much into the details, but the European Open Science Cloud is an initiative, right, to create like make it easier for scientists to be more fair, right? This is like findable, accessible, interoperable, and what's the R stand for? It's down here, reusable, right? So to provide like resources to allow people to do that. So some of those resources are like things like data lakes, like being able to store lots of data in various places. Some of those things are cloud-like resources, and that's the one that I'm focusing on. So they have this thing now, it's for the last almost a year, I think now. these things called the European Open Science Cloud, EU node, right? So what they are is access to cloud resources for anyone at an EU institution. I guess it's academic institutions. I'm not 100% sure what the restrictions are, but you get different amounts of credits on this platform based on your type of role. So if you're a researcher, you get more resources than technical staff, but both people get resources. So you can so on this web address you can log in. I've already logged in, so I can go visit the user space. So this is me, this is their platform. You can see you can do different things. You can do file syncing, you can have interactive notebooks, you can do something related to large file transfer. You get there's cloud container platform there as well, so Kubernetes and stuff. And then you have access to virtual machines as well. You have credit in this environment. So if you go down here, you can look at the credits you get. I think it's 500 credits per, at least for academic staff, it's 500 credits per period. And I think the period is 3 months, something like that. It's probably detailed down below. You can create projects where you can collaborate with other people, and that project can get its own resources as well. So you can access more resources that way. And it's early days. So if you were going to create a project, probably now is a good time to do it while they still have resources, because I imagine ultimately the resources are finite. They are growing these resources, but they're finite. Yeah, I think it's 90 days. It's 90 days for the credit cycle. And then you can turn those credits into something, right? So for example, for virtual machines, you can turn them into virtual machines. I've already allocated one. So I've allocated a small one that costs 10 credits a day. To use that, you can go bigger, you can go medium, you can go large. I think it's possible to even get GPUs on here as well, but for that, you need quite a few credits. So that, and then basically you access those credits, and then you have to do something with those credits, right? So now you turn the credits into kind of quota that you have for resources, but then you need to somehow do something with that quota. You can do it through this cloud container platform link, right? So let me think. This is actually the same one as the virtual machines. I think that looks the same, more or less it's the same, yeah. There's a way to get access directly to the OpenStack environment. I can't remember exactly how to do it now, but it's in here somewhere. But we're not interested in that today. So what we're interested in is in the Tools Hub. So once you've turned your credit into quota on the cloud resource, then you can use some of these tools here. Move this out of the way. Then you can use some of the tools. So there's you can get a Galaxy node. So for those of you who know what Galaxy is, you can get a simple compute node. You can actually get a Slurm cluster. You can get other things as well. But down here somewhere is the Easy Compute node, right? So I've created a tool on here as well so that you can quickly spin up an Easy Compute node. And to spin up that node, there's little buttons over here, right, for various things. You can show details of, well, actually, we can have a look at what I did over here. So you can see information about this. That's some metadata, but then they use what's called Tosca files. I can't remember what it stands for, but it's basically like a resource definition file format. And it's complicated, but I didn't create this, right? So one of the cool things is that my Easy Compute node is based off of this one. And I did that by just making a copy of this and editing to suit my needs. So basically, I started from something that was already pretty complete and did all the things like getting a fixed IP and a disk, attaching a disk and all this kinds of stuff. So I don't actually know how you do that right now in the Tosca environment. I just edited the things I needed to edit to get the Easy Compute node to work. And so the most important thing in here, so among all this stuff, there is somewhere down here, the implementation. And what that is that you just say something that happens at when the node starts, right? There's different ways I could have done this, but this is the way I did it. And then basically I just give a path to a YAML file. So it uses, I think under the hood, it's using Ansible, I think, under the hood. So it's a YAML file for the syntax. And then if I can get the Zoom controls out of the way, I can open that link. If I remember, no, that didn't do it. I can't remember how to get the controls out of the way. What's the shortcut? Control, Alt, Shift, and I. There we go. No, I copied the wrong thing. Where did it go? Copy, paste. So in here, let me make that a good bit bigger so that you can actually see. Um, Most of the work is the installer scripts that we actually have in our demo repo. So that's like more or less OS agnostic installer script for CVMFS and Easy. So that it runs that. It also messes around a little bit with the default shell. Unfortunately, right now the default shell in the compute node thing is just SH. So I didn't like that, so I changed it to Bash. So that's just setting the shell to Bash for everyone. And then I messed around. So the default OS is Ubuntu, and Ubuntu with Easy has on initialization, on default initialization, there's some stuff going on related to less pipe. So the less pipe in Debian is different to the less pipe that you get in Easy. And so when you initialize the environment, these don't really match anymore, and you just get a little warning. I didn't like the warning, so I cleaned that up. And that's basically it. So that's the things that are run once a node is booted. So it's run for every instance. And then on the basis of that, then let's go back here again. You can you can deploy that. I'll try and do it, and it'll complain if I do it. So it'll say, "Oh, your tool has already been deployed," because I deployed it before we started today, because it takes a couple of minutes for it to actually deploy, and I didn't want to wait. When it is deployed, you'll get a notification over here saying that the tool has been deployed. I don't know what happens if I click on that. It just brings me back here. And then if I go to deployments, I'll see status has been deployed. It's been deployed on the compute service, container service. But then I don't know what to do next, right? So the documentation, even here, is not that great. And that's my fault. I probably could have improved that. But actually what you do over here is you click on this tab, and it would give me some information. That's the tool output, right? So it tells me the fixed IP address that I have to contact to log in. It tells me my username over here, and it gives me a private key to log on. And originally, it wasn't available to copy this key straight up, but now it is. So that's easier than it used to be. So I'm going to copy that key, and I also need to know let me set up the login first. So I've got that key. So let's this one. We're going to paste that key in here. That's a private key, so anyone who's very, very quick with screen recording can copy that and log in. And then I can use that to log in, ID underscore node. Let's see there. So the user is cloud admin, and the IP address, it's probably not that one. 8947.191. And what was the last one? 145, I think it was. Let me check that. 245. Okay, and I can log on to that now, and it'll log me in. I could have been a bit smarter in my little script to pre-populate the cache a little bit. I wasn't. So that first login takes a few seconds because it needs to populate the cache with the compat layer and everything. But now it's available. And with that, then you get all the software that's available in Easy. And that's basically what I have for now. Could it be improved? Yeah, it could. So we can add the support for GPUs in there into that script as well. That wouldn't be too hard to do. If we went the route of collaborating a bit more with EESSI, they could provide S1 servers at the locations of their sites. So wherever they're hosting these EOSC node infrastructure, if they had a Stratum 1 at that place, then this experience would be even better, right? It'd be very, very quick. You'd be talking about near instant logins and things like that, because you'd have much faster access to files. I did notice that it's still not using the CDN, so I hadn't must have done something wrong to not use the CDN. So I checked the configuration. Maybe we can check it now. What's the command again to check the CMS? Um, what's the command status?
I
I
guess
think it's need sudo. No, I want the one that gives me more information. Bob, do you remember what's it called?
You want
Uh,
to print the full configuration, you mean, or
no, I just want to know who it's talking to for Stratum 1. I can't remember
I
that.
think it's status minus v and then software.easy.io.
Uh,
minus V could be enough, I guess, if you have not.
Or stat, I guess, stat minus v, not
no, it's
stat.
that.
Apparently, that's the difference. Yeah.
Yeah, so it's not talking to the CDN. I thought this would actually talk to the CDN, but I guess this is closer, physically speaking. So, um, I was thinking about forcing it to talk to the CDN, which I also could do in the configuration that I create, right? Um, so it's yeah, but it was not slow. It was not crazy fast either. I'm sure it could be better. So yeah, could be some performance improvements to be made, but I also could fake this a little bit just by including that initialization into actually I do have it. Oh yeah, I could actually run that command. If I ran that command as part of the script or the Ansible script, it would pre-populate the cache a little bit. And so it would feel a bit more instantaneous when I actually do the final login. Yeah, so that's it. Just to give you an idea, and so that you all have access to these types of resources. So if you actually want to use this stuff, it's free and available to you.
Okay, thank you, Alan. And it's a very nice thing that you have accomplished already. And maybe if we see that uh, there are interest in this, so we can dedicate a session and explore more on how things are working and how to get access to those VMs and what does how to further tune or configure access to easy as you have shown. So maybe that could be one thing on our schedule as easy happy hour sessions. So one thing I forgot to mention in the beginning that the session is being recorded, although that session is almost over. But and we recorded Alan's private key. So so
I'm going to kill that machine's gone.
yeah,
It'll be
yeah.
gone in 2 minutes. So don't worry.
So I will stop the recording now in case anyone would like to share something without being recorded. But before that, I would just like to remind that next session will be how to contribute software package to Easy. So within the topic series, we already have covered how to build locally on top of Easy with different approaches, and today with the buildenv. So in the next session, we will see how we can contribute software packages to Easy, and hopefully you will also join the session. I will stop the recording in case anyone has something to add related to Easy.